Hi, we're going to take a look at grading the FRQ from 2006 Form B about golf balls and the distances that they travel. Part A says if the manufacturer sets the mean distance to be equal to 288, and what is the probability that the ball randomly selected will travel too far? You have to read the problem to know that 291.2, the balls can't travel farther than that. So that is going to be our definition of too far. So what I'm looking for right here to begin this particular problem is a normal model drawn for us. And the normal model needs to have the n, the mean has to be identified, 288. The standard deviation has to be identified. Now this person identified it up here, okay? I need it to be right there, so my person is not going to get credit for this particular problem. Now the other thing that I'm going to need to be able to see is the shading. That the mean right here is 288. Now they're identifying a z-score here. I'm going to skip over that for a second. I need that to be identified as 291.2. But the basic thing I'm looking for is the shading going to the right hand side, and my person does have that. They just have labeled it a little bit differently, and remember this is going to be distance traveled. So it's only going to be a check mark for the shading and labeling that cut point. So far we have 2 points, one for labeling the n, the mean standard deviation, and one for the labeling and doing the shading. The shading is important, okay? So the next thing I'm looking for is the p ofs. We're looking for p of x being greater than 291.2. There needs to be a z-score calculated. Now this person did the z-score calculation right there inside of the actual p of. I generally have taught you how to do it separately, but it ends up that the z-score is 1.14. You probably did the work over to the side, and then you have p of z is greater than 1.14. And then what's missing here for me is the normal CDF for 1.14 to 999. And I'm not going to give credit for that, although the AP did because they showed direction on their shading. This is just a backup. I do want to see the calculator speak, but it's probably, if you have everything else, they're not going to care that it's there. I expect it to be there. And then the answer is 0.1271 is the answer. I'm going to give a check mark for having the right answer. And so far, in this particular problem, there are, let's see, 1, 2, 3, 4, 5, 6 checks. My person got 4 out of 6 on this particular section. All right. So for part B, it says, assume that the mean distance traveled is 288, and we are testing 5 balls independently. What is the probability that at least one of 5, and as soon as you read that, bing, 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 you should automatically in your head go, oh, this is successes out of a group, okay? That this is going to be a binomial model because we have successes out of a group. So I see a lot here, they actually in words write out that it's a binomial distribution. I'm going to show you the way that will be probably shorter and sweeter and more like how I've taught you to do that. I need for you to identify the binomial model. The sample size or the group size is 5. Now the probability of it exceeding that distance is the answer that you got from part A. So I'm going to put 0.1271 right here. Okay, and if you have that, you are going to get credit. Now, what I'm looking over here is that they identified it in words, they also identified their P, and they also identified their sample size or group size. So my person would get credit. Now, I doubt you did that on your paper. I'm going to need to see this. If you do not have that, give yourself an X. You have to identify your model. Now we're going to have P of, we want greater than or at least 1, which is x is greater than or equal to 1. So I need to see that. I don't see that on this paper, so I'm going to give an X on this particular one. Then we're going to have 1 minus, remember the at least problems are 1 minus what you don't want, binom CDF. I'm going to have to like go a little sideways here. 5, comma, 0.1271, comma. We want 1 and above, and what we don't want is the 0th one. Okay? So give yourself a point if you have that written down. Okay, I'm looking over at my person's paper. I see that going on right here, but I'm going to grade it based on what we've learned how to do. I'm not going to give credit for that. And then the answer, if you put it into your calculator, works out to be 0.493. Now I see my person has 0.493, so I'm going to give a check mark for that particular part. So there are 4 checks for this particular problem. My person, I'm only going to give 1 out of 4, although the AP will be much more generous because all the basics are here. It's just not in the way that I taught you how to do it, which makes it a lot harder to grade. So we're going to grade it based on how I taught. Okay? So 4 points for that particular problem. The last one, the manufacturer wants to be 99% certain that a randomly selected ball is not going to exceed the distance of 291.2. What's the largest mean that can be used to calculate, to be used in the manufacturing process? Okay? Well, just off the bat, they give you a percentage. They want you to go backwards and find the mean. So the big thing is remembering that the z-score formula has all those different pieces in there, but the basic beginnings of this problem is going to be an inverse norm problem. Okay? So the place that we're going to start right here is a picture, and the 99-cent has to be labeled. All right, so I see that going on. But what's missing here is that I need to see on this particular problem. Unfortunately, we don't know all of it. I guess I'm not going to give points for that, but I do need to see the picture of that sort of marked up. We are looking for the mean. Okay, we know that the standard deviation is 2.8 though. Okay, so normally I guess I would check for having the n and the 2.8. I'm not going to give that a check. So 1 point for having the graph, the normal model drawn with the 99% on the inside. And so the next thing I'm looking for is z-score equals inverse norm of 0.99, which is equal to, all right, 2.326. So if you have that been done in your problem, okay, go ahead and give yourself a check mark. My person has the z-score sitting over here, but it's too rounded. I am not going to give credit for that. I do want to see the setup for the z-score. All right, let me scoot this up a little bit. And I want to show how I arrived at that. And I also, on z-scores, especially involved with like z-stars in the future when we do confidence intervals, you don't round it that too early. Make sure you give at least 3 decimal places. Okay, so now, on the z-score formula, which is x minus mu over sigma, we know the z-score is 2.326. We know the x, too long, is 291.2 yards, minus the mean. That's what we're trying to figure out, and the standard deviation is still 2.8. So if you have that set up, give yourself a check. So my person did set that up, so I'm going to give them a check right over there. Okay? And now, solving that using algebra, the mean works out to be 284.676. So my person did algebraically solve it and get the correct answer for this particular problem. Okay. So in this particular one, there are 4 different checks that that we're looking for. My person got 3 out of the 4. All right, so that means to calculate the final answer. Let me scoot this down. 6 plus 4 is 10, plus 4 is 14. So figure out of 14. Okay, figure out how many you got. 1, 2, 3, 4, 5, 6. So my person got 8 out of 14. Okay, and we are now done grading this particular question.